Okay, so today's lesson we're going to be having a look at sample spaces, and a sample space is a way of writing down all of the different outcomes for two possible probabilities. So in fact it's probably worth writing that down actually. So a sample space is a way of looking at all the possible outcomes for two events. So a sample space is a way of looking at all the possible outcomes for two events. Okay, so let's have a little cool look at this one. Maybe don't worry about getting this one down in your notes straight away because it's not too difficult here. So we're just going to talk through this one. We'll have a look at another one in a second. So William throws two four-sided dice. That's a little bit different, isn't it? And adds up the score. Complete the sample space diagram. Okay, so if he's throwing four sample spaces, now the numbers on his dice are these numbers here, which is going to be 1, 2, 3, and 4, and the same down here, 1, 2, 3, 4, and it says that he adds up the scores. Okay, so if we are working here and we want to fill this in, we're going to add up the scores. You can get this down if you want. So it'll be over here, 1 plus 3 is equal to 4 here. 1 plus 4 is equal to 5 for this one. 2 plus 3 is equal to 5. 2 plus 4 is equal to 6. 1 plus 3 is equal to 4. 3 plus 2 is 5. 3 plus 3 is 6. 3 plus 4 is 7. And then it's the same here. 4 plus 1 is 5 here. 4 plus 2 is 6. 4 plus 3 is 7. And 4 plus 4 is 8, like so. So there's our sample space, and they can ask us some questions. So maybe we'll have a little think about one of the questions. One of the questions might be, what is the probability of getting, let's say, 5? So the probability of getting 5. Now with this one here, it's the amount of 5s over the total outcome. So there's 1, 2, 3, 4 5s out of, well, it's a 4 by 4 grid, so it's going to mean there's going to be 1, 2, 3, 4 by 4, which is going to be 16. So it's going to be equal to 1, 2, 3, 4 over 16, which does cancel down to 1 over 4. So here's your answers to those. Filled them in. Yeah, super. Alright, this one's a little bit different because this time instead of having 1, 2, 3, 4 and adding them, it's just asking you to list all of the outcomes. Now, I've already done some of them for you. Now, if we're going to finish this one off, it's going to be, well, this one here is going to be, it's B and then 3. Again, I'm going to do this quickly just to kind of crack on with it. This one would be A4. This one here would be B4. This one here would be C and 2. This one here would be C and 3. C and 4. And then the last one would be B and 1. B and 2. Sorry, D and 1. D and 2. D and 3. And D and 4. Super. Nice and easy, that one. There's your answers. Now this is where we kind of step it up a little bit. Now not too much, because we did have a look at this in the first one. But it says here, now they don't always give you this sample space here. Sometimes they just ask you to do it and then you've got to work it out yourself. But this one here says Ben throws 2 dice at the same time and then adds up the score. The sample space diagram below represents all the possible outcomes. Find the probability that Ben gets a total score of 6. So, this one here, we need to think about the amount of 6s we get over the total amount of outcomes. That's how we work out probability. So in this one here, we've got 1, 2, 3, 4, 5 6s. So the probability, and this is how we'd write this, the probability of getting a 6 is equal to, and it's going to be the 1, 2, 3, 4, 5 there, over the total amount of outcomes, which in this case is 6 times by 6, which is 36. Now you could count these if you wanted to, so like 1, 2, 3, 4, 5, 6, 7, 8, but we know that we can just do 6 times by 6, which is 36. And can I simplify that? No, I can't. So that there is our final answer. 5 out of 36. Nice and straightforward, but these come up all the time. 5 out of 36, brilliant. So this one here is a little bit better, a little bit trickier. Again, it's not that difficult. In fact, have a little go at this one yourself. Okay, so I'm getting quite a few different answers here. I'm just going to have a little look at the ones which we have got. So, looking at this one here, the thing is, it says that it's strictly greater than 4. Now, that's really important because it means it can't be 4. So, what we've got to do is we've got to count all the ones which are greater than 4. So, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so it's going to be, now the way we'd write this one here is it's the probability of being strictly greater than 4 is equal to 30 out of 36, which a lot of you got. I'd probably simplify that down because sometimes they do ask for this. So I'm going to divide this by 6. So that's going to be 5 over 6. Now it doesn't ask you to simplify it down. You would get the marks for this one. You would get the marks for this. But we can simplify it down as well. Super. Okay, so 30 over 36, brilliant. Alright, so have a little go at this one yourself as well. Have a little go at this one yourself. Yeah, we can get this one down as example 1. I wouldn't worry about drawing the... you can draw them if you want. Yeah, maybe get this one down as example 1. Okay, I'm going to go through this one. So here we've got 2 spinners, a yellow spinner and a red spinner. You can't see that they're yellow and red, but they're yellow and red spinners, and they're numbers 1 to 3. And they are numbered 1 to 4. Here, like so. So we're going to write down here, it's going to be 1, 2, 3, and 4. And then down here it's 1, 2, and 3. And it says that Jane adds these 2 numbers together. So let's put a little plus in the corner there. And it's going to be 1 plus 1, which is 2. 2 plus 1 plus 2, which is 3. 1 plus 3, which is 4. 1 plus 4, which is 5. And then the same for the others. 2 plus 1, which is 3. 2 plus 2, which is 4. 2 plus 3, which is 5. 2 plus 4, which is 6. 3 plus 1, which is 4. 3 plus 2, which is 5. 3 plus 3 is 6. And 3 plus 4, which is 7. So some of you might have spotted that actually what we've got here is that to get a total of 8, well, it's impossible. We can't get a total of 8. So actually we didn't even really need that sample space, did we? Because the probability of getting 8 is equal to 0. Super. Alright, so have a little go at this one yourself. Have a little go at this one yourself. So you are going to need your sample space for this to do this. let's have a look at this one together then. So we've got one spinner which is 3 by 3. We've got another one spinner which is 3 by 3 as well. So we're going to write down 1, 2 and 3. 1, 2 and 3. Now with this one, the difference with this one, you've got to be really careful. It does say here that she multiplies these two together, doesn't she? So if I multiply these two together, I'm going to get 1 times by 1, which is 1. 1 times by 2, which is 2. 1 times by 3, which is 3. 2 times by 1, which is 2. 2 times by 2, which is 4. 2 times by 3, which is 6. 3 times by 1, which is 3. 3 times by 2, which is 6. And 3 times by 3, which is 9. So what's the probability that she gets a 4? Well, the probability that she gets a 4 it does. I've made a little mistake, haven't I? What a silly Billy. Look at my mistake. So my mistake was that it says 1, 2, 3, and then the other one says 2, 3, 4. So I need to put on here 2, 3, and 4. What a silly Billy Mr. Adams is. So 1 times by 2 is 2. 2 times by 2 is 4. 4 times by 3 is 6. 3 times by 1 is 3. 3 times by 2 is 6. 3 times by 3 is 9. 4 times by 1 is 4. 4 times by 2 is 8. 4 times by 3 is 4, 8, 12. Brilliant, thank you for correcting me there. So, with this one here, how many 4s are there? Well, there's 1 4 here and 1 4 here. So there's 2 4s. So the probability... So the probability of getting a 4 is equal to, well, there's 2 4s out of 9 in total, so it's 2 out of 9. 3 marks for that. Okay, 3 marks there. Let's just check that. 2 out of 9. Thank you for correcting me. Let's move on to the next one then. So Natalie is playing a board game. Natalie is playing a board game. She must throw 2 6-sided dice. She must get a 1 on each dice to start the game. Work out the probability she will not start her game on the first go. So with this one here, we're thinking about this sample space again, aren't we? So we need our sample space here. Which is like so. Okay, and then we've got 2 6-sided dice, so it is 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6, and then we add them together. It's going to be 1 and 1, which is 2. 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. Probably don't need to do all of these. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 11. Last one. 7, 8, 9, 10, 11, and 12. So work out the probability she will not start her game on the first go. Well, the probability she will not start a game, well, she needs a 1 and a 1, doesn't she? So she needs 1 and 1, which is 2. So the probability she will not start her game on the first go is all of these here. She must get a 1 on each dice to start the game, yeah? So the probability is the rest of these. So this is going to be the probability that she will not start. Is equal to, well, the rest of them is 35. If there's 36 in total, which is 6 by 6, the rest of these is going to be 35. So it's 35 out of 36. 3 marks for that. Brilliant. Alright. So I'm going to have a go at these. So if you're catching up with this, here's some questions for you to have a little go at. So pause now and have a go at these if you're catching up. Here's some more questions on those if you're catching up. And here's your answers to those if you're catching up.